Good afternoon, everyone. It's been, I'm sure, a long and very technical conference here. And this talk is going to be a little bit different in the sense that what I'd like to talk to you about are some very basic, really fundamental principles of information visualization design, the kind of challenges that we face in this discipline every day, and a few practical little winning ways that I have found that help me along to make information tell stories about numbers that people actually want to believe. So my name is Mark Grundland, and as you can see, I do a lot of things in life. Basically, I am a freelance consultant, and I help my clients bring innovation to market, turn good ideas into great businesses. And along the path, I've worked as a product manager, a software designer, and lately I've been doing a lot of consulting around data science, helping people see the meaning, the insight, the power of the numbers they store on their hard drives. So today I'm going to talk about just one of the things that I do in life, and that is information visualization. And this is really a good place to start because information and visualization has been around with us for a long time. I would argue that it is as old as art. In fact, some of the very first art we made was a scatter plot. Now, the remarkable thing is that to this day, we still don't know what it means because the people who made it didn't yet know how to write. Well, things have changed. We're no longer putting marks on cave walls. We're posting on Facebook walls. But the same challenges of getting a message across, a message that is going to stand the test of time, they still apply. Now, here's a remarkable story. And it happened right here in London. And it is the reason why some of you are alive today. And this seemingly insignificant plot started the modern science of epidemiology. There was a cholera outbreak, and a fellow called John Snow was seeing people die around Soho. Now, cholera back then was a real killer, just as it is in developing countries right now, and what he knew that these deaths were clustered in a certain area, and he traced this back to a water pump that was that was built over a cesspool. Now, what he needed to do was to convince the authorities to build sewers underground rather than overground, and being able to not just relate the anecdotal evidence, but to actually, with each mark, show where the deaths are, help them to connect disease to its cause. And in fact, the pump you can still find, I think, at Broadwick Street today. Now, if in the past, visualization has changed the way we see the world, it is becoming ever more critical. Who here is seeing this graph for the first time? A show of hands. Well, this is the famous hockey stick graph, which is arguably the most controversial and the most important chart in science. Literally, our future depends on how we read, how and interpret this graph enough to create policy change. And the remarkable thing is what an ordinary graph it is, when so much has been written about it and its consequences, whether that information is true or not. And this is really what happens when scientists make their own visualizations without really regard to the fact that they're going to be seen on TV. And really, in science, we are so used to being objective. But in a sense, that's never as objective. Whoa, hold on. Never as objective as we think. For example, how we present two incomparable axes, the change in temperature on the y-axis and years on the x-axis, says, how do we scale that presentation? Can tell completely different stories. For example, if you make this graph like a long time series, all of a sudden what's happening at the end doesn't seem so dramatic. Of course, that goes the other way around, So what do? Well, visualization design makes decisions. That's what designers do. And the decisions we make necessarily affect which interpretations of the data are facilitated and which are impeded. We are creating subconscious impressions in the minds of our viewers, and those impressions can be manipulated, they can be, of course, made honestly as well, but mostly they need to be communicated, as you see Al Gore is trying to do. So imagine you are making the most important graph in the world. Let me ask a simple question, is how do you decide what its aspect ratio should be? You see the dramatic effect it can make on how people judge the data at a glance. So what should the aspect ratio of a graph should be? Like I said, I'm here to address some very basic questions. So please, should it be 1:1? 1, it's fair and square. A show of hands who thinks it should be 1:1. Okay, no one thinks that. Well, very well. What about sort of more like what they did, which is, 3:2? It's wider than it is taller. It's a little bit like a landscape photo print. Is that the right answer? Anybody? Anybody wishes to raise their hand? Okay. No one, no takers here. Okay, well, next option. So how about we take the golden ratio? After all, it's like the way nature arranges seeds in a sunflower. Leonardo da Vinci drew it in his notebook, so it must be beautiful, pleasing, and right. Anybody wishes to take the golden ratio as the aspect ratio of the most important graph in the world? Oh, a couple of hands went up. Well, there we go. So we have a default option. But let's see what else we can do. We can ask a perceptual psychologist. And they will tell you that we are pretty bad at making judgments of deviations from the horizontal and deviations from the vertical, but we're pretty good at judging deviations from the diagonal. So the idea is to adjust the aspect ratio, so we bank at 45 degrees because it is perceptually optimal for orientation discrimination. Who thinks that's the right way to choose the aspect ratio of the most important graph in the world? Any hands? No, one person trusts psychophysics. Amazing. Well, next, of course, we can ask the mathematicians. Now, the mathematicians believe that aesthetics is an optimization problem. So, of course, what are we going to do? We're going to minimize arc length by keeping area under the plot constant. That's clever, because that means that we get the shortest line showing the change in climate. Is that right? Is the mathematical criteria right? Any hands? Any takers? Wow, no one trusts mathematicians. Amazing. A few people will take the word of a psychologist. No one We'll trust mathematicians. What a life. Okay, so we're all software developers here. Me too, by the way. Let's just take the screen size or the window size as given. After all, an iPhone can't be wrong, and besides, it fits. So obviously, that must be what the user wants. Anybody believes that this is the right way to decide on the aspect ratio of the most important graph in the world? One person does. How many of you, when creating a visualization, has actually used this heuristic? I wonder. And finally, you could ask a graphic designer, the people who really make their living telling stories. And they'll say, you ask them, what should an aspect ratio be? And they'll say, it depends. Well, what does it depend on? It depends on what is the story the user is meant to believe. Now you see how two books can easily get written about a simple chart when you start taking that kind of a attitude towards being honest, credible, faithful to your data. Who, by the way, thinks that's a good idea? 1% in the room. Well, very well. What about all of you who didn't raise their hands? How do you think we can decide to choose the subconscious impression that the most important chart in the world is going to make? Well, the amazing thing is that information visualization is such a young science that we don't really have answers that everyone believes. It just depends where you're coming from. It does indeed. Now, if you think that this problem is somehow isolated, let's take another very, very, very important applications, and that's Google Maps. Now, we are living on a sphere floating through space. And the trouble with spheres floating through space is that when you try to put them flat on a table, you'll wind up ripping their surface apart. You see, there is no way to represent the Earth on a map that doesn't distort distances, directions, angles, shapes, or areas. So we have to make a choice. Just like with the aspect ratio, and just like with the aspect ratio, that choice is very important. Now, Google, in their infinite wisdom, of course it's Google, they must be right, chose the Mercator projection, which was originally designed, by the way, for ship navigation because it preserves angles, not areas. And a lot of people in the world are not pleased with that. Now, the problem you have is in a sense political, because we make judgments based on what our charts are saying. For example, on this chart, it looks like Africa is about the size of the United States. Maybe a little bigger, but certainly not the size of the United States, China, India, and just about all of Europe put together with Peru thrown in for good measure. Now, think about it. This is the map of the world that our children are growing up with. This is their sense of how big we are in proportion with the rest of the world none of us get to see. And of course, we can understand here in this room that this is just a projection of three-dimensional space onto a two-dimensional plane, but that's not what ordinary people think. And it is by setting up their subconscious bias to what kind of world they're living in that the choices as people who design information visualization really make a difference. So, we can actually quantify this distortion using Tissot. So, indicatrix. And the idea is very simple. Just at every point on the sphere, you place a little circle, and then you see how your projection distorts the circles onto the map, turning them into ellipses. And of course, you see, right, it's obvious how the Mercator projection is biased towards the northern hemisphere, which has a lot of landmass and where rich people tend to live versus the equator, where most of the poor people live. Of course, there are better choices that we can make, like the Robinson projection, which actually I would suggest you use when you wish to depict a visualization on a global scale. However, that's not the only choice we have. You see, because if distortion is inherent, then let's admit to it. So cartograms distort the size and shape of regions in order to make their area proportional to the variable of interest. So this is what they look like if what we're interested is the geography of landmass. But is that really so relevant and so interesting anymore? After all, we don't navigate our own ships. We fly by airplane. There are some much more important variables, I think, in the world than landmass. Population and wealth seem to be what drives our economy and our everyday life. And I just wonder, what would it be like if along the map of the world we know so well, in our geography classes, our children would grow up with maps like this. Maps that really show how wealth is distributed and how Africa vanishes off the face of the earth. And this is the essential point. The way we visualize sets up our audience for the kind of interpretations that they are going to make. Right? You showed it to me, and now I see it for myself. That's what this is all about. So, what do we have to work with? If we want to express numeric values that have absolute magnitudes, the trouble is that the ordinary human brain doesn't think like a mathematician. Visual perception only makes relative judgments. So what do we have to work with? We've got position, which by the way, can be seen relatively accurately. But afterwards, things sort of go downhill. So we got position, shape, length, orientation, area, and volume, hue, saturation, brightness, texture, transparency, alignment, proximity, containment, connection, labels. We've got glyphs. We can put in motion and flicker, and if we get permission, electric shocks. I don't know what else. Wow, so much choices. The challenge of information design is how do we make those choices in a way that does not mislead our viewer? Well, let's see just how easy that is to do. Here's a little puzzle. Which is bigger and by how much? So who here thinks the square is biggest? Show of hands. One person? Yeah, okay, good. 2 people? Okay. Who here thinks that one of the long rectangles is bigger? Anybody? 3, 4, 5, something like that. Okay. What about the fat rectangle? Is he the big guy? Haha, 1 person there. What about the rest of you? You think? Do you think who thinks they're all the same? No. Bullshit. Now, There is only one problem here. This is exactly the tool we give financial traders to get an overview of the market. You know, that's why, after all, their jobs aren't supposed to be easy. They get paid for something. Okay, well, let's see how let's see just how this all works. So who here thinks that, just please bear with me, this is important. Who here thinks that these two circles are the same size? Please, believe in the authority of your own senses, not what other people seem to think. You are the best authority to make this judgment. Who here thinks they're the same size? Who here thinks they're different? Really? Would you like to explain?
I just went for the second option.
Okay. Now, who here still thinks they're the same size? Now, who here, based on the authority of your own eyes, the one incontrovertible truth you have that dwells within you, who here believes those circles are the same size? Well, what does same size mean? Does it mean what is drawn or what is seen? You see, because that question is disconcerting. Why? Because what you see here is a bubble chart. And a bubble chart is the way we figure out that UK government spending makes no sense. I know, these guys are just blowing soap bubbles out there, you know? And amazing, because the Guardian did a good job here in the sense they labeled the bloody bubbles. Okay. But the perception of size happens far quicker than you can read a label written in white on gray. And that has a problem because by the time you've read the label, your mind has already made a judgment, a preconception, a bias about its magnitude. And that's the kind of challenge that we as information designers have when we actually want to be understood. Now, here's an interesting situation, one that happens every day, actually. Who here, which is brighter? The rectangle on the left or the one on the right? In the first one here. Left. What about in the second one? What about in the third? Now, the problem, let me see, is that your visual cortex wasn't evolved to read graphs. It was evolved to hunt monkeys and birds in the rainforest, where being able to draw distinction in shadow and light meant the difference between starving and not having children or being the king of the feast. And that has certain implications. This is actually what's going on. Now, think about it. This is on the brightness channel, one of the very best channels we have for communication, where, in fact, what we are communicating is not the element, but is its surroundings. And this happens, of course, in real life when we're trying to color in our maps. A region of blue surrounded by red is seen different than the same region of blue surrounded by blue. That's just a fact of life. And if you don't like it, you do something else. Oh, damn it, we're back to the previous problem. Well, what are we going to do? We're going to call in the Guardian. Now, the Guardian here begins to present a real solution in the sense that they label things. And they add callouts, which convey the story. And they give different perspectives on the data. They have only 4 gradations, which are easier to read than a continuum. Clever guys at the Guardian, but not everybody's got that kind of budget. I don't. So for my sins, I get to analyze the performance of online advertising campaigns. It's actually fun in a perverse kind of way. So here we are looking at comparing impressions to clicks over content in various categories. And if I just left it at that, I don't think the client would really get the picture because it's not so easy to read. But we add things in. We turn a bar chart into a traffic light bar chart. The first thing we do is which I did was put labels both of the categories right next to the numeric labels rather than putting, let's say, numeric labels at the end. So it's easier to read. And then just make it really easy. I find that the more people are paid, the harder it is for them to read a graph. This is just my experience. So now everybody sort of knows about traffic lights, so that's how we color our bars, and then we use the light, the traffic light to show whether a given content category is green, meaning good to run a campaign on. Okay, let's see how Now, one of the things we want to do in visualization is to work with color. And color is tricky. And this is just one of its many tricks. Who here has ever used like a rainbow palette, a rainbow color map? Well, they suck. For some things. Here are just some of the things that go wrong with them. First of all, hue order is not obvious. Does green come before yellow or yellow before green? Is that immediately obvious? I don't know. But there's something worse. You see, we perceive hues as as having different categories, meaning red is categorically different from green and green categorically different from red. Well, if you have all of them present, what happens is that we cannot help but see false edges where the transition between one hue and another takes place. This doesn't happen in a gradient between 2 colors where you have a smooth gradation. And even more so, even more interestingly, if you put a bright color like yellow and a darker color like blue on the same spectrum, well, obviously, the eye is going to go straight for the yellows. And you can avoid this by making the rainbow color map more isoluminant, and then, of course, your yellows turn to brown. But really, the most remarkable thing is that these palettes tend to make details a lot harder to see. They create false details, while the real details are not nearly as remarkable. Well, and that is because the human visual system is much better evolved to perceive small discriminations in brightness than in color. Nature sort of gave us color vision as an afterthought. So let's look at another problem that takes place, which is transparency, the overlay of information layers. And the normal way to implement transparency is you just blend them together using linear interpolation. So that's an averaging operation. It reduces variation. And then you've got a little problem that you can see right here, where the edges, where there is no overlay, are more vivid than the interior. So if you just implement transparency in the obvious way, you can get reduced contrast, dull colors, detail loss, and a lack of selective emphasis. And I noticed this problem, and I decided to get a PhD from Cambridge for trying to solve it. And I invented image blending operators that are designed to produce composite images that preserve the key visual characteristics of their components. There's like color, contrast, detail, and salience. And this really illustrates just how less vivid any sort of standard transparency effect is compared to natural photographs. Of course, that's because you need to use the right operators. So we can put the contrast back in, we can emphasize vivid colors, bring out the detail, and then there's a really neat method called salience preserving compositing, which takes each component image, predicts which region of the image is most likely to attract the eye, and then preserves preserves the appearance of that region while creating this seamless composition. But of course, you know, in the real world, you just hack it, right? Hell yeah! So here's how the world looks according to Facebook. So, and to make this graph was it's a beautiful trick, really. You take the arcs, right, the friendship connections, and you take them in order of decreasing lengths, and then you color them according to a suitable gradient, with the longest ones being dark, and then they turn blue, and finally the short ones are white, and a map of the world emerges. Really cute. So I'll just very quickly say one other thing. This is a project that I worked on in news visualization, where we wanted to visualize how online news evolves over time, and I started out with talking to customers, doing focus groups, and we decided to address like the basic questions people have in public relations. What do I say? Who do I say it to? And did it make any difference? Now, I designed sort of objective metrics to try to address these questions, and this is like the first or second prototype I came out with. And it's like a Swiss Army knife, like many exploratory data tools are, meaning you can do everything, but that's not what the end user wants to do. So I needed to simplify this, and so I went from that to the idea of a news radar, which is this notion that familiar visual metaphors make interpretation easier. So let's put together a speed gauge, and the radar, and this is what I got. And I don't quite have the time to go through it in detail. See me afterwards if you're interested. But the idea was just very simple: is that for each news article, you can see how many similar articles were published before and how many similar were published afterwards. So you can compare the number of precedents to the number of consequences. And the influence of a news article may be defined as the number of consequences minus the number of precedents. And that's what we put along the arc. And then the radius is simply the amount of attention it got, which is the number of precedents plus the number of consequences. And the little dots are each news article. And then we can sort of take a median, and that is the effectiveness of a news organization. So I'll go very quickly through a few more examples. This is a brilliant technique when you need to make sense out of point clouds. It's called spheres of influence. You put a sphere at the center of each point with its radius equal to the nearest neighbor distance, and then you connect every pair of points whenever those spheres of influence intersect, and you can make that work in any dimension with any distance metrics for which you can readily calculate neighborhood intersection. And the amazing thing is that it kind of makes the same pattern as human perception would. What it lets you do is to have a principled way of turning a point cloud into a graph. Now, now graphs are fantastically useful. One of the more amazing practical uses is that they're great for being able to visualize hierarchical data structures like XML, JSON, or HTML. I've just got thrown at me a few gigabytes of JSON data, and I want to be able to see at a glance whether each JSON record has similar or dissimilar structure. And right now I've got a huge scrolling tree view. If I had a gallery of graphs, I could actually see what's going on. Now I am going to okay, I'll go for this very quickly. This is a beautiful application in text visualization where what we want to do is make more meaningful word clouds. And the way we do this is by taking the text and writing it around the arc, and then placing each word at its average location in the text. So when you click on it, right away you see whether it is present throughout the text or only in a certain region. And of course, you can do how you order the elements of the text that it comes from is up to you. For example, this is done in reading order, but you could use, I don't know, sentiment or some other criteria. Of course, you can turn word clouds into landscape. Wonderful technique called self-organizing maps. Another interesting issue is that we are often dealing with graphs, and graphs which are quite difficult to handle on because so many nodes are connected in so many different ways. This is a lovely system from Health Imagination. And the first thing to notice is that graphs are best at interaction. So it is only when you hover over a node that its connections are emphasized. And that means that we can plot it in a far better way. So I know this screen isn't great, but basically these are various medical symptoms that go around the circle. And by distributing your nodes on a circle, you can plot the connections in a very clear way. And there's a wonderful technique called hierarchical edge bundles that can help you do it. So finally, what's the secret to great information visualization? Well, this is what I know. Start with the user, not the data and not the graph, and ask some good questions. What will this allow you to do that you can't do now? What difference can you observe in your business? What value do you expect that this will add to your business? What will this let your customers do that they can't do now? What difference can your customers observe in their business? What value can your customers expect that this will add? How does this fit with your strategic plans? How will you know that this has been a success? How will you build on success? And then, when you have a damn good answer, and you've slept, oh, I like sleep. When you slept one night and another on it, ask yourself the real question. So what? Now, I like to just leave you with a little point for discussion, and I know I'm almost through, which is what is the future of information visualization? Will charts become more interactive? Will graphic designers get better at adding subtle animation? What impact will augmented reality glasses have in making information visualization an everyday part of our lives? Will cheap displays make ambient visualizations ubiquitous? Will virtual reality and gestures interfaces change how we interact with data? My name is Mark Grundland. These questions passionately fascinate me. I'm right now looking for something interesting to do, and if any of you have a data set or a business problem or just a fascinating challenge I could help you with, do let me know. Thank you.
You pointed the way that multiple displays of the same information can aid understanding, and you also touched on interactivity as being a useful tool. In your experience so far, which one of those do you prefer, or you prefer them both together?
Interaction. Simple graph where you can poke the data is what gets people thinking. If you display a dozen graphs, each one with a different perspective, wow, that really makes them think, but is liable, more often than not, to leave them confused.